Welcome back to Drone Racing Academy. Today's video is all about the TBS Tracer. As racers, we're always trying to chase after the fastest possible video link and control link, and today's all about the control link. TBS first brought us the Crossfire, which is a super popular control link, but now they're back with a 2.4 GHz version that promises a lower latency while still keeping a good range performance. So, let's dig deeper and find out what that means for us. In the meantime though, don't forget to subscribe with the button below and click on the bell so that you can know when new videos come out for you. So, without further ado, let's find out what this really means for us. Drone Racing Academy. So TBS Tracer, this is the latest control link from TBS who brought us the Crossfire, which almost everybody uses and a lot of racers use as well. The Tracer is the 2.4 GHz version of that, except there are some differences. Crossfire uses LoRa, whereas the Tracer does not. According to Trappy, Tracer is optimized more for a low response time, and LoRa it basically is more geared towards guaranteeing your transmission of your packets over long distances or in tough RF situations, which results in sometimes resending of information which is not optimized for speed. And that's the reason why I chose not to use LoRa in the Tracer. The other competitive product, the Ghost, uses LoRa, so it'll be interesting to see how it all shakes out and see which one ends up being the best. But today we're going to focus on this. So, given that TBS has a very strong reputation in control links, I'm super excited to find out what the Tracer can do for us, especially as racers who care not so much about range, but more about response times and also, I guess, about performing in very congested environments. We have very different requirements from freestyle long rangers who really want to go really, really far, whereas for us, we tend to run 6 to 8 pilots in the air at the same time in a small space. That's a whole different set of issues, and also we care a lot about the response time. So, how does that do? We're going to find out in a field test shortly. But before we go into that, let's talk a little bit about latency. Quick primer on what latency means. It's just basically the delay between your movements on your radio to sending the signal to the flight controller. That's the radio link latency. There's also other bits of latency between the flight controller itself, getting the instructions, and then sending instructions to the motors after the pit loop. And then, after that, from the camera back to your goggles. So there's a whole system of latency built into what we do when we fly our quads. Obviously, there's also our own human response times, which is about 120 milliseconds. Now, for the latency of the radio links, we're talking about 3 milliseconds for the Tracer, and then there are some competing radio links like Access, which is about 9 to 12 milliseconds, and then there are other ones that are a bit longer. The question a lot of people ask is, hey, if your human response time is 120 to 150 milliseconds, is it really going to make a difference if you change from a, 20 millisecond radio link to a 3 millisecond radio link? Will I even know the difference? That is a great question, and I have a hypothesis as to why it matters. Now, you're probably correct in that you won't be able to tell the exact time difference between a radio link that is 12 milliseconds to a radio link that's 3 milliseconds, but you have to remember that this is in a system. And the system itself, when you add it all together, has significant latency, and it's all an additive process, right? If you're talking about a parallel process where different things are happening at the same time, then your latency is always going to be dependent on the longest, slowest delay in the chain. So, in that example would be your human reaction time, but because this is a linear system where you're starting off from sight, you see it, and then you make a reaction after your human response time, it all adds together to form the entire length of the reaction time chain. If you reduce any part of that step within the chain itself, in terms of latency, it serves to reduce the overall latency in that entire chain of the processes, which then produces a different result. So what does that really mean? You might not be able to perceive the exact time difference of you moving the sticks to the quadcopter reacting, But because your body has gotten used to a specific level of latency when you fly, so for example, when I see an image of a gate coming at me at, let's say, this distance, that's when I usually start turning. One, obviously, is to pre-turn, but secondly, you're also building in latency that your body has gotten used to for your system. And so when you turn, then your quad actually does what you want it to do, and it turns in at the time that you want. Now, when you use the lower latency link for the RC link, or if you reduce any other parts of that chain of latency, what's going to happen is that what you see and what you do in your hands is going to cause a different result, because your entire chain of latency is now shorter. When you see it this distance away and you start turning, your quad's going to turn earlier than you expect, and you're going to end up in a slightly different trajectory than what you're used to. Obviously, that's going to be a different result and outcome from what you're expecting, and it will surprise you, and that's probably when you would see the impact of using a quicker radio link. Now, it might sound like a bad thing in that it's surprising you, but it's not, because it now means you have a more direct control over the radio link, and you have a more direct control of your quad, that you can now, shorten the distance of when you have to make that turn versus what you're seeing on the cameras. So that's my theory of how this could all come into play. And so to answer the question of, hey, if our human response time is 150 milliseconds, what difference does 5 to 10 millisecond make from a radio link? And this is the reason why I think it actually makes a difference. So if my hypothesis is correct, you're going to be able to see the difference mostly in turns and making sharp turns, and in high-speed turns and high-speed shooting of gaps and so forth, where your body's going to have a bit more time to react to it, and you're going to be able to make corrections quicker. So let's see if that's really the case. Before we get there, let's take a quick look at what else is inside the box. You've got antennas. So the Tracer uses Diversity Immortal T antennas. They're shorter than the standard Crossfire antennas, and this is because the Tracer uses 2.4 gigahertz as a control link versus a 900 something megahertz of Crossfire. And as you know, this length of the antenna is proportional to the length of the wavelength, which at a higher frequency is lower for the Tracer. Now, the starter kit also comes with 3 Tracer receivers. I've already used one, so there are only 2 here. The Tracer receiver is very small, and I liked that about it, definitely. They also include an inverter chip, which is useful if you have the QX7 of the FreeSky, which needs an inverter chip. I personally use the FreeSky X90 2019 version, and that does not require it, so off that goes. Some wires and I guess a header pin, which I'm probably not going to use. And that's about it. There's no manual, I think. Yep, no manual in the box, but there's a very, very detailed and great manual available online on their website. Highly recommend you check that out. TBS has great documentation, and the Tracer is definitely an example of that. So, let's take a closer look at what the receiver looks like. Alright, so this is the receiver. I'm going to do my best to make it focus on it. It's very small, incredibly small really. The 2 connectors for the antennas here. You've got the bind button, which I never really had to use. I'll explain why in a second. And that's basically it. No headers, which I like. Everything is just purely soldered on. You've got the 4 solder points here. As far as I can tell, it is not silk screened. So you should make sure you check the manual so that you are soldering to the right points. Now, the next question is, how much does this all weigh? So let's find out. 2 antennas and the Tracer receiver. Okay, receive antenna number 1, antenna number 2, and the receiver itself. Let's find out. It is coming up to 2.6 grams. Let me just weigh that again just to be sure since it's so light. Yep, 2.6 grams. That is really, really light. especially considering that it's got 2 antennas. So that's impressive, and definitely something that is important to us as racers. So, in terms of setup, how easy was it? I'm going to have a setup video that's separate from this that goes at length about how to set this up, but generally speaking, it was really easy. Wiring this up is just 4 wires. You've got the ground, 5 volts, TX and RX to your flight controller, and that's it. Very standard for a receiver. Mounting of the antennas, and I've mounted it here on the Floss 3. This is the part that was a bit trickier for me. I'm not used to working with Immortal T antennas. I usually use dipoles on my other control links. So as you can see over here, I had to fasten both sides with a zip tie that kind of holds onto this plastic piece right here. I don't know how this is going to hold up to punishment from racing and turtling and all that crashing. We're going to see how this holds up as time goes by, and I might change the mounting to a different position if this ends up getting chewed up or it ends up sliding up and down the arms. But for now, it looks secure enough, and I think it's mostly out of the way of the propellers, so I think this might be a good spot to mount this. If I find a better spot, I'll let you know. But for now, this is how I've mounted it. Wires coming up here, the zip tie holding on to the plastic T section, and that's what's holding it there. There's a bit of slop to it. You can move it slightly, but it's mostly stable enough. So we'll find out more about that. But generally speaking, it is more difficult to mount the Immortal T's versus the standard dipole, but not overly so, and it's something that I can probably get used to. I know TBS sells the dipole antennas for the Tracer as well, so at some point I might switch to that because we really don't need that much range. So if the performance is similar enough, dipoles are probably easy to deal with. So that is the setup. And this one obviously just plugs into the back of your transmitter. If you have a full-size bay, they also have a smaller version of this. Plugging this in, I ran my radio on OpenTX 2.3.10, I want to say, and everything works out of the box. No nightlies required like Crossfire shot, so this runs standard OpenTX firmware, which is really nice. Setup-wise, very simple. You just change your model to using external and CRSF, which you would think stands for Crossfire, but CRSF is actually the protocol that TBS created, and they're using that for both the Crossfire and the Tracer. So CRSF is the one you want to go with, and then you basically use the same Luascript to control Crossfire that will also control the Tracer, and that's how you do your binding and so forth. And that takes us to binding. I mentioned before I didn't actually end up using the bind button. So what that does is, on the first boot up, the receiver is already in bind mode by itself automatically, so it's really nice. All you got to do is go on the transmitter and radio side, select, go into the Luascript and go to bind mode, and then that's it. It just binds by itself, finds it, and then it's done. Next thing is it automatically updates the firmware receiver over the air, so you don't even have to do that. So the receiver between the transmitter and the receiver, the firmware between transmitter and receiver is always in sync, and it's really pretty hands-off at that point. So that's really, really nice, and I'd like to see more of that with other control links in the future. We really should not have to mess around with jumper wires to update firmware at this point. So overall, setting this up, super painless, and I got everything working. Telemetry I struggled with for a little bit, but after updating to the latest version of Betaflight, that cleared up. So I've got telemetry working, I've got Betaflight Luascript working, so like being able to change your VTX frequency from your radio off of a Luascript, really nice, and it works perfectly on this, right? So all in all, setup super easy. Receiver size, great. Weight, great. Everything fit in my stack super easily. Antennas, not as easy to deal with as dipoles, but I managed, and I think this is a pretty good mounting spot for it. Alright, now that we've seen what's in the box, let's take a quick look on the bench. What it's like to run the Tracer on your radio, and what the settings look like, and so forth. I've got my quad plugged into the computer just because I'm bench testing. So, to access the control of your Tracer, you hold the menu button and go to Luascript, you go to Crossfire, and you see you have your Tracer Micro TX, your Wi-Fi, Nano RX is connected. I've already binded this, and then you have your Betaflight. So the Tracer menu itself, you get to set your failsafe. You have binding options. You can set your max power between 25 millivolts to 100 milliwatts. I use 25 mostly for racing just because we're not really going that far. I'm going to do some testing to see if 100 makes the link a bit more robust or faster, but for now 25 is working well for me. I turned off dynamic power just to keep it consistent. You can also control your VTX using your tracer, but I've chosen to use the flight controller to do it. Now on the receiver side, you're also running this script. Now the interesting thing is this usually takes a while, which is weird because Betaflight Lua loads pretty much immediately. So you give it a while and it loads. If you move your cursor too quickly during this page, I'll show you an example. It would generate an error. It says script killed CPU limit. So be patient. So if you're patient though, and you let it load, and sometimes it takes a while, which is really weird because I'm right next to it, and I honestly don't understand why it takes this long to load. But it's not a big deal because you don't come to this page all that often. So you have your channel mode. I have it set to 8. The other option is 12. For fastest latency for racing, you're going to want to use 8. There's really no reason to use 12. I've set telemetry on so that I can access my Betaflight Lua and also get voltages on my radio. It's all working beautifully. Failsafe mode, I've set to cut. I think it defaults to something else. Since we're using flight controllers for safety, we should definitely use cut. We're not using MavLink, nor are we using the battery sensor on the RX. And then over here, you can get to set the channel mappings. That's all default. I wired it based on the default wiring, so nothing to change here. You can also change your channels, and then it gives you some versioning information here. Now, there's also a menu in the Crossfire for Betaflight, but as far as I can tell, it doesn't do anything. I've let it load for a while and it just stays on the screen. I'm not quite sure what it's supposed to do yet. If I find out, I will let you know. Now, I'm a big fan of Betaflight Lua. So over here, Betaflight Lua, you can see that it loads, and then you can change your VTX settings and so forth, all from your radio, and this all works over Tracer, which is really, really nice. So that's a quick run through of the settings that are available on the Tracer. If you've used Crossfire before, this is going to be very familiar to you. Nothing new here. Everything works as it should, and it's quite easy to do. The only part that's a bit weird is how long it takes for the receiver options to pop up, but once it does, everything works great. So no main issues here. Everything works really nicely. Okay, so all that's left is really to find out how does it do in a racing environment. So with that in mind, I took it to the field. It was a race day, so I actually ended up using my main squads first during the race because I didn't want to change anything big during a race. But after the race, I flew access all day, and then after the race itself, I tested the Tracer setup, and here's my findings. This is my first pack of the day with the Tracer. I had flown the race using my previous radio controlling because I don't want to change anything during race. This is my first pack, but as you can see, I was already feeling pretty locked, which is surprising because most of the time when I change equipment, I'm kind of stumbling for a bit. But this felt really good right off the bat, and as you can see, I think the feeling that I can describe from this is that I was feeling very locked and in direct control of my quad, which gave me confidence to do things a little bit more riskier than I was previously used to. And then I can tell you that in certain elements is where this kind of radio control link with fast latency really shines. One of them is the dive gate over here where I can make minor adjustments very quickly. The other one's the U-turn, which you just saw over there. That's a lot tighter than I was able to do with my other control link. The other one too is this sweeper. It doesn't make that big of a difference, but at the end of the sweeper, when you have to make a change in radius, that really makes a big difference because you're coming at it really hot, and being able to change the curvature quickly really helped. The last one is really the punch-out gate, which I'll talk about when we get there, but As you can see over here, my U-turns are pretty tight, and it felt a lot better than it did with my previous control link. Over here into this other U-turn, definitely really nice. Again, on the sweeper, not much of a difference there until you get to this part where you have to make it tighter, and that's really a lot better. Now onto the punch-out gate. Notice how small that window of time you have to get through it, and I think that's another area where the Tracer really shines. Now onto the ladder, which you just saw. It felt a lot closer to the pole that I was able to hug compared to my prior link setup, which is interesting because you don't think of a ladder as an area that requires kind of twitch reflexes, but I think I was able to make minor adjustments in the ladder a lot quicker that results in me being able to just hug the ladder really close, and I can see the big difference between my ladders of the Tracer and on my regular equipment. So that's an interesting phenomenon that I was not expecting. Now back as we finish the last lap over here, again, U-turns are really nice, and overall I just felt really nice and locked on the. So back to the room for conclusions. So that was my impressions of the Tracer. I think we've got a clear winner here. For racers who really care about having a very fast link, both from a video and control perspective, it's a no-brainer. I'm comparing it to the system that I've used for the past 8 months or so, and once I switch to this, it's super clear to me that this is much more direct and much faster. And the biggest difference I can tell you is when you're trying to make a quick change because of either a mistake that you made, or you're slightly off your line, or you're seeing someone fly in front of you, the ability to make that quick change is a big difference. Lines like sharp turns, as well as ladders and so forth, they also felt more tighter, and it felt more direct of a response, so I can feel more closely linked to the quad. The easiest way for me to explain this is it's kind of like playing a video game online. If you play shooters, for example, if you have a high latency, you're going to compensate for that. You have to, right? If you for example, playing a shooter, if you have high latency, you're going to shoot ahead of where the person is going. It's called leading your shot, because you have to compensate for that lag, and your body and your brain kind of gets used to it over time and does that compensation automatically, and you don't really think about it, and after a while you stop feeling it, right? But just because you stop feeling it doesn't mean it's not there. Now, when you switch to a faster link after you've been playing that way for a while, if you say you switch your internet to a much lower latency internet, you're going to be missing all your shots because you're leading it, right? You're shooting ahead of where they should be. And it's kind of the same to this, where when you switch over to a faster link, before when I was on the slower link, I didn't feel, there was much latency. Everything felt fine to me, right? For a second I tried this. The difference is pretty stark, especially at the scenarios that I described before. And at those points, I suddenly felt it, and the control was that much more direct that I can do a lot of things that I wasn't able to do before. Like I was able to hug the pole tighter on the ladder, and I was able to make quick changes to my line when I kind of veered off, and I definitely noticed that. Now, for things like, parts of the track which are like more smoother, like long sweepers, where you're not really doing much in terms of control changes, it's going to mostly feel the same. And for parts of the track that are more kind of spread out, where you have a lot of time to prepare for it, your body's able to make that compensation where it won't feel that much different. But it's definitely at times when you have to make emergency change to your line, when you've made mistakes, or if there's something that kind of jumps ahead of you, unexpectedly, and you have to make a quick reaction, that's when the system shines the most. So, with that in mind, who is this for? This is for the racers that, want to get the best possible performance out of their gear. With the faster link, you're going to be able to fly that much more, with that much more direct control over your quad, and it feels that much closer, and definitely a big help. And I'm definitely going to switch all my quads over to this in the near future, and get used to this kind of a better link speed, and hopefully my flying will improve as well. It's also useful for freestylers who do proximity or do tricks that are a bit more kind of reflex driven, right? If you're going to fly close to things, if you're going to do quick flips where you have to react quickly to like over flipping or under flipping, or even if you flip and you almost hit the ground, right? Being able to rescue yourself in those situations, I think you're going to see a difference by using a faster link like the Tracer. Now, if you're going to be flying long range, or if you're just cruising high above into the clouds where there's nothing around you, faster link won't really help you there. You know, there's nothing around you. So you're probably better off with something like a Crossfire to get, you know, that extra distance. Although I've heard that this does really well at long distance as well. I haven't tested that because I'm a racer. We don't really fly that far. But yes, generally speaking, anyone that needs to make quick adjustments or quick judgments and movements would benefit from a link like this. So that is my conclusion of the TBS Tracer. We are going to do a blind test as well, just to remove any subconscious biasness. And if you're still not convinced from this test, maybe that will help convince you. That's going to be coming up in this channel. I'm also going to be putting up videos to teach you how to set up your tracer, from unboxing all the way to putting in your quad, all the way to tuning it to get the best possible performance out of it. So that's going to be coming to this channel as well. So please do subscribe on the button below and click the bell so that you'll be able to get notifications whenever new videos come out. I hope this was helpful to you. Stay safe out there and happy racing.